Okay, we're a multidisciplinary engineering and business simulation organization. We work exclusively in oil and gas sector. We're going to share with you a case study. We worked for a large oil and gas pipeline company in North America, one of the largest in the world. It transports 1.8 million barrels per day through Canada, US. They approached us some time ago, about 18 months ago, with some very unique business problems. And we'll explain a little bit about the environment that we were working in. We do work from an engineering perspective so we're not what we would consider deep practitioners in simulation, but we do simulations, we do advanced optimization, and we do predictive analytics that come with that. The whole focus is business as opposed to technology. We had a large pipeline operator that was challenged to quantify its system's impacts. It had an environment that it was highly regulated. It didn't have some of the tools and techniques that a for-profit organization might have. They were challenged to determine what the existing tankage at an upstream terminal, whether it be adequate to store some deferred batches. They had a client or a customer that was erratic in receiving its commitments. It wouldn't take the batches. It wouldn't take the oil they had committed for, due to other internal constraints. And it was problematic for the larger pipeline company because, of course, it caused very large chaotic waves through its network, its pipeline network across North America. The challenge with that is it's not a local problem, it's a large network problem. So we had 5 terminals, we had a number of kilometers and miles of pipe to connect, and the challenge we had was how to abstract that now at a simulation level with enough materiality and accuracy that it actually represented the real problem. So we had a very unique set of circumstances, and we had to apply both engineering principles as well as our business knowledge and our simulation knowledge to arrive at a solution for that. To better understand the system dynamics and overall impacts, we had them authorize a business network model, so it was both an economic impact as well as an engineering impact. Why simulation? Well, the organization was largely a spreadsheet-based organization, very traditional, very old in some respects in terms of how to approach the business. Again, it's a more regulated entity. So it didn't have the tools and techniques that a larger for-profit organization might have. They had no prior modeling experience. Simulation was not a common concept with them. And again, they were heavily spreadsheet-based, so if it wasn't a static analysis, single-point solution, they were really challenged to understand how this might work. So we had a situation where we had to educate, develop, and then train all at the same time as creating a very advanced model for them. And it was a relatively complex one for us as well because of the geography involved and the challenges we had we'll be describing in a moment. My colleague Dimitri will speak about the implementation challenges that we were faced with. We have a quote here from Thomas Edison, and if you try 10,000 ways and you continue to find ways to fail, that's one more way, one more step along the path to success. So the point of that quote is that we wanted the organization to learn how to experiment, to learn to be a learning organization. And to do that, they needed a very advanced simulation tool that would allow them to look at the real results. And we're going to speak more about that because it's a very important aspect of the frontier that we're all working in. All the practitioners in this room are part of that new transformation that's occurring in the marketplace. We had 2 business objectives. Essentially was to understand and evaluate the impact of the customer behavior downstream. So they had a customer not receiving its product it had committed to. It simply turned off the valves, and this pipeline operator then had to decide what it was going to do with that excess capacity. It could be up to a week and a half worth of product, which is an enormous volume when you deal with pipelines that are 42, 48-inch pipe pumping 24/7. So it's a very large volume of oil. The question is, now what do you do with that oil in the system? Do you have enough upstream capacity in that system to actually absorb that unexpected quantity? And how does your network then respond to that unexpected quantity of oil? The second aspect we were looking at was how do we now debottleneck, identify and remove bottlenecks in the system to allow them to have greater throughput through the system. It's a classic network problem. Metrics we looked at were throughput and infrastructure capacity. Those that understand pipeline business, there's a lot of variable inputs. So we had a lot of variables that we were considering in this model. And part of the challenge was making it flexible enough that we could actually reframe the problem, because they had numerous problems and challenges they were looking at. So they needed a network model that would allow them to reframe and readjust and recalibrate as they went through this. Okay, Dimitri.
Thank you, Alan. Quick break before I start going in the details of the technical details of oil and gas industry. When we approach business user and we ask a simple questions, what do you understand about simulation? And what do you want to see at the end? All of them is like, what do you mean, simulation? It's all that exercise to explain to them. And then one of them is actually came and showed me the picture and said, hey, this is what I think is simulation. And here was a Star Trek, actually, fan. And as you can see here, this is a holodeck that's where you can simulate anything you want. Just input, and here's your simulation. That's what they wanted. They wanted a model that actually can do anything. You can do simulation of the pipeline business, you can do customer behavior, you can do impact of the oil leaks, and all risk impacts that to the business. We said, future, not today. And that's where we had to go through exercise and step back and educate them about simulation. At the end, we came back and agreed that simulation for these purposes is actually has capabilities that will allow them to do number one, discover. Discover the system bottlenecks, understand those system bottlenecks, and also evaluate them. Also assess and measure the associated upstream and downstream, as Alan was explaining, to the business impact. It also had to have two more capabilities, because they still wanted to have that holodeck that we can generate and simulate anything we want. They wanted to have the capability to easy scale, to grow the model, add additional lines, add additional terminals, and evaluate the impact, but easy. Also, adopt and adjust to the changes condition. That means the system has to be smart by taking business rules and adopt and change. Again, sounds like simple simulation problem, but it wasn't. It was actually quite complex. Now, before I jump and talk about the modeling challenges, there's multiple modeling challenges we had. This project lasts for 8 months, where we thought it's going to be only 2 months and we'll get over and done. But unfortunately, there's multiple challenges that we had through the project. This is only 2, but there is hundreds of other problems. I just picked those 2, but before I explain how we dealt with them and where we actually, what the path we took, I want to give you a quick 60-second one-on-one oil and gas and fluid dynamics course. Just humor me. Imagine a pipeline that is 5,000 miles long. Imagine that pipeline is actually 48-inch diameter. When you're working with the pipelines on that size, the fluid becomes compressible. You've heard like, oh, you can't compress fluid, maybe a little bit. Actually, on that sizes, the fluid becomes very compressible. And what you have on input and what you have on output won't balance, even if you're going to pump with the same rate. The problem is also becomes more complex when the temperature changes. Because when you have 5,000-mile pipeline, it goes through the 10th state at least, and it can go from -60 to +60. Your volumes change dramatically. And if you have a little bit of material degree in engineering, like in the structural engineering, you also will understand that the pipeline itself, because you have over 2,000 psi, it's like almost like your car washer pressure inside the pipeline. And when it goes over the mountain, it goes to 10,000 psi. That's why your pipeline actually breathing, and it can go 2 to 4 inch in the diameter changes. And as a result, your volumes change. What you have on the in, it's not the same as out, especially because the transportation time, sometimes transit time, takes up to 2 weeks. If you're trying to solve a short-term decisions, make short-term decisions, it won't work. Simulation model becomes very complex. Now, if you ask engineers, do you do simulations, they will say, yep, actually a lot. And in the last 5 years, the oil and gas industry invested more than $500 million in simulation. but on the molecule level, on integrity, on the leak detection, on those flow measures. In our case, you heard Alan, he asked the business question. Can we actually take these volumes and transport, and what is the impact of behavioral impact to the throughput of the pipeline? Unfortunately, these models couldn't answer. These $500 billion in investment couldn't answer because they are designed for different purpose. We can't simulate the model, and actually they tried. They tried to take hydraulic models, the flow models, and they tried to build actual terminals, tanks, and so on. But it didn't work because they become so complex, and it took more than 6 months to develop them. And actually, every time when you have a slight changes, you have to change the whole model and invest another 6 months of development. As a result, our approach was modeling challenge. What is the abstraction level we're going to take with that entire system that doesn't talk only about pipelines? Add now 47 commodity types, add now 73 tanks, add some major terminals and 26,000 kilometers, not just 5 miles, which is approximately 9,000 kilometers. Now you just triple and quadruple all your complexity on that level. Also, the next question was, which modeling tool we're going to use? Is discrete event going to work, or should we use agent, or is it combinations, and which tool would work? After evaluation of different vendors and different software packages, we had criteria. We went through a month of evaluation. We presented back, and we decided to go with AnyLogic. And again, a couple next slides will show you why we decided to go with this on that route. But in a nutshell, because we had the challenge of modeling entire system, we needed to decide what is the abstraction level we're going to take, how far we abstract. And it was a tough job. And we have some of the modeler here who actually done some work because this model was developed in collaboration with AnyLogic. And I can tell you, you can talk to him later, it was a challenge to decide what to abstract because everyone was talking about molecule level. They wanted to model every molecule, not to abstract to the business level. Another one is model goodness of fit. If we're going to abstract, is that still answering our question? And they didn't like that it's going to have actually plus minus 10% or confidence level. They wanted 100% confidence and 100% accuracy, which is impossible. But again, it's a challenge to explain to those executives how it works. Scalability, it's another feature. It's another feature that actually AnyLogic done very well out of the box. You can replicate components, you can configure the system on the fly by reading data, configuration data, where the other models, mostly it's a coding. It's a hard coding, and it's going back to those flow models or hydraulic models. It's a lot of work. And reality check. Of course, we needed to loop back and double check that all those work from a project perspective. Now, the second challenge I mentioned, it was modeling paradigm. Which modeling we're going to pick? I can tell you it was, again, quite a time to explain why agent-based, what is agent-based, and it was tough to explain because, again, we were talking to really smart engineers, but structural flow engineers, schedulers, they didn't understand even what is agent-based or discrete-based system dynamics. We had to abstract, we had to talk, and finally we decided, we gave up, and we said, we're going to build a model, and we're going to prove it's going to work. And that's how we achieved. Unfortunately, I don't know, maybe it's a shortcut, but we just couldn't spare more time from a project perspective. We already were late. But now, for you guys who understand the difference between those stuff, I can tell you the agent-based was selected mostly because, as Alan stated at the beginning, we wanted to understand the impact, behavioral impact of our shipper, the consumers, on the entire system. That's why we needed to generate models, simulate that behavioral impact. Also, there's a lot of other components in the network that actually have independent properties, business properties, that behaves independently, and based on that moment in that network will have different outcomes and different patterns how it behaves. Anyway, we used all three methods in the model. If you want more details, we can share with you during the break. And ultimately, we implemented, and initial challenges, as I said, was attempting to model the entire system, choosing the right modeling methods, We decided to model for specific business questions. It was a challenge, but at the beginning, you've seen that the question was about throughput. We decided to focus only on throughput because there's so many other factors in oil and gas business, like quality, like infrastructure. There is other questions, but we decided to limit that. Also, from methods, as I've explained, we decided to use all three modeling methods. Now, benefit, we had quite a relatively robust system. As a project team, we were quite proud of what we delivered. The problem is it took 4 months to validate that model. We thought we were going to be done in 2 weeks. 2 weeks, that's all. 4 months. It's not the building model the problem was. It's validating, because business asked us so much to include in this model that they didn't know how to test it. Because some of the stuff they've never done. That's why that was a little bit of a challenge. We even didn't validated absolutely all the components. We validated only a portion that we needed to answer the question. And now one of the questions, IT came back and said, hey, another tool, another problem in our shop. But business convinced them that there is no overlap. It's a different tools. Those hydraulic models still required to do integrity, leak detection, and some other analysis. And these models are required for business purpose, to answer some logistic questions, supply chain questions. And with that, I would like to welcome back Alan to talk about business outcomes and benefits.
Okay. So, the best part. These are the outputs that we received. Phenomenal results. We had to go through a very long validation exercise. It took about 4 to 6 weeks to build. 2, 3, 4 months, depending how you look at the validation process, and an additional 2 to 3 months to do the actual analysis, final recommendations, and so on. End to end, about an 8 to 9 month process. But at the end of it, the learning was phenomenal, and the results, the ability to experiment, were through the roof. They could not believe the results. We're not able to share the specifics of the business case, but I can tell you the savings were in the range of $50 to $80 million. For a $3 million investment, they saved north of $80 million. That's just on the capital spend side. In addition, they saved over $2 million a month additional, or created additional throughput of $2 million a month revenue per month from this point forward. You're looking at a $100 million benefit for a $3 million investment. Phenomenal results. So we're trying to demonstrate this to the industry, and it's almost at a point of disbelief. They go, how could that be possible? It's possible. And we have a demonstrated example here where that's possible, but again, that would not have been possible to the extent that we did achieve without any logic and its multimodal approach. The flexibility, the ability to interact, the ability to experiment, was key to that kind of success. But these are the kind of results that are possible with this kind of tooling technique. I mentioned earlier about the frontier. So we're at the frontier as practitioners of simulation optimization work. In the past, we had static spreadsheets. We looked backwards. We looked at how the world was. Today, we're looking at how the world is. Simple simulations. How will the world look in the future? There's an interesting Forbes magazine article that came out last week. If you have a chance to pick up a Forbes, I recommend it. The title is, "The Future of Innovation is Simulation." So perfect example, and here's a relatively unaware observer of industry realizing that this is where the future lies. So we've got a demonstrated example of the power, the savings. We have people understanding, not just in industry, specific individuals, experts, and so on, mathematicians, but practitioners, business leaders, and average people understand the power of this technology. And again, with any logic's help, with any logic's capability, we were able to demonstrate that. Along with that comes this notion of optimization and the more predictive looking forward, the forecasting, which again is the future focus. Okay. Are there any questions? Yes, sir.
Have you used this simulation for sizing a system?
Sizing physical, like line sizes?
For instance, sizing the pipes?
We haven't taken it to that level yet. Where we have experimented is total capacity. And then, of course, you've got a number of engineering questions. You've got pump sizing, you've got compressor stations, you've got the size and diameter of pipe. There's a number of engineering variables that go with that. That would be a next stage of experimentation. So we took it at the business level, but there's another layer below that, which is more the practical engineering design level, which then you'd look at the various interconnectivities, for example. So which pipe connects to which pipe, but also what capacity of pumps do you need? Those become engineering questions, and then you can model all those as scenarios as well. By the way, we also created a tool that helped us look at the experimentation. So once you start looking at all the various scenarios, the question goes, okay, so which scenario is my best one now? And how do you define best? What do you optimize on becomes the question. So as a result of this work, we've created some automated tools that help the user also experiment with those tools to understand not just that particular scenario, but also the combination of events that give me the best outcome.
So you mentioned that this was motivated by a client that wasn't receiving the deliveries.
Mm-hmm.
Now that you guys more fully understand the impact of that, have they thought about using that knowledge in future contract negotiations?
Excellent question.
Yeah.
You want to speak to it?
That's exactly was the strategy, and the outcome was quite amazing because, abstracting the names, CEO of the company, of the network company, actually now, instead of just calling that shipper and saying, hey, your behavior has actually cost me money, he calls and says, this is my money cost, and this is what I'm suggesting. And the shipper actually said, I don't care. I'm the biggest client. I walk away, you lose the business. That's where they decided, no problem, in 2 years, we're going to be renegotiate contracts. Now we know our tolling fees, we know our penalties. Now it's like you're using our storage instead of just throughput storage, but as a storage, because this is not the warehouse. Those are terminals, it's breakout terminals. Those are terminals, in case if the line goes down, then the terminal it's just capacity, like almost like cushion, just to create that intermediate storage. But it's not a storage to the shipper, but they were abusing. Now they can change those contracts, and that's exactly what they're doing right now. They're taking those rates, calculated the right rates for the contract negotiation. Yeah.
Can I just comment on that one further item? And that's that it no longer becomes an argument or a discussion between you and them. It becomes, let's interrogate the model together. And it's a very collaborative approach, which is, again, a novel concept. Again, you've got competing organizations, for-profit organizations, now sitting side by side and saying, we have a joint model that we can now interrogate together. We both understand better what's the impacts are, the correlations, sensitivities, and so on.
I had a question about, you told that the network in the system has been optimized based on the behavior of the agents that was customers. What kind of optimization have you used? Because there are some challenges, for example, when the customer needs oil, we have to just provide it.
Absolutely.
What kind of optimization tool have you used?
Very good question as well. In this situation, the optimization was done manually. So they did a number of scenarios. It was a team or a set of experienced schedulers that then decided what was optimal. Now, we had some discussions with them, and one of the points to follow this work is that there needs to be some future discussion about what does an advanced mathematical optimizer look like. What do they want to really optimize on becomes a question. And there's some follow-on work that's being proposed to go into this whole space of advanced mathematical optimization. To finish this story here, they simply didn't have the ability to do that. So they relied heavily on individuals, on people, and very experienced people. And of course, the question with experienced people is, are you looking at all the possible variations? Are you looking at all the possible variables? Just because you've done it one way for 35 years, does that indicate it's the right combination? So you get some optimal results as consequence of that. But again, the next stage with this particular client is to take them through that whole learning curve around advanced optimization.
Great.
Thank you.
Okay, thank you very much.